Okay, quick little preview explanation of how I would like to see you do these problems that involve simplifying by combining like terms. So here is the first example of two that I will go through before you practice. So here we have an expression, and you can see that we have terms separated by addition symbols. And one strategy I like to use, you can do this with color or you can do it with different numbers of lines, is to first just look through and identify any terms that we have that we consider to be like. So starting from the left, here we have 3y. Is there anything else like that? Well, it just so happens that right next to it we have a 2y. So each of those get one line under them. And then at the very end here we have another one. So that gets one line. So everything that is like has one line under it. Now we go on to the next term that doesn't have any lines under it yet, and we'll give it 2 lines, signifying that it's different. And anything else that is also like with y squared would get 2 lines, but I don't see any. And then finally, here's our 5, which is a constant, and it gets 3 lines, and nothing else is like it. And once we have all of our terms underlined, we know that we have covered everything. Now we can start combining. So here we have our 3y, our 2y, and our y. Remember, this is the same as 1y, so it does have a coefficient of 1. And we can just add those together. 3 plus 2 plus 1 is 6y. Now, because there's no other math to do here, then we can just copy the other ones down. Technically speaking, that would be correct. And the way we know it's correct is if you look at our terms, we have 3 unlike terms. Nothing else can be combined. This is as simple as it can be written. And finally, it's best to write in biggest exponent to smallest exponent. So the best way to write this answer would be like this. Okay, next example. Now you can see on this one, I have included one with subtraction. Let me get rid of that symbol. Okay, so here we have subtraction, and what I'm gonna just try and get you in the habit of doing is, before you do anything, subtraction can be very confusing. The first step we want to do is just change subtraction to addition. And it might seem silly, and you're welcome to tell me if you think it's silly, but it's what I have always done, and it has worked for me. So the way we do this is, anywhere you see subtraction, we're going to go through and change this to addition. And we do that by going plus the opposite. We can put that in parentheses. Plus the opposite. We can put that in parentheses. Plus the opposite, and we can put that in parentheses. So just to clean this up a little, I'll show you what we end up with is 3x squared plus negative 2x plus 7 plus negative 5x squared plus 3x plus negative 2. One thing you'll notice is, and I try and demonstrate this, is showing each step may seem tedious and time-consuming, but it is also the best way to lead to correct and accurate answers, and so that's the habit I would like you to get into. Now we can do just like we did in the previous problem, go through and identify all like terms. Starting with 3x squared, is there anything else that is also like x squared? Well, this one is also like x squared, and it's the only other one I see. Now here is one with x. Is there anything else like x? Well, 3x is also like x. And then we're left with our constant, and all constants are like. Okay, so we've accounted for all of our terms, and now we can go through and add them. Let's start with our x squareds. So we have 3x squared plus negative 5x squared. We add the coefficients. 3 plus negative 5 is negative 2. Okay, and sometimes people even like to sort of put a little slash through here to show that it's already been taken care of, so that you don't forget any. Now we go into our x terms. Negative 2x plus 3x. Negative 2 plus 3 is 1. So we can call that 1x or just x. And now those are taken care of. And all that's left is 7 plus negative 2. 7 plus negative 2 is 5. There is our answer. And we've crossed out everything so we know that they are all accounted for. And now it's going to be your turn to practice.